All right, let's look at this problem. So the electric field of an electromagnetic wave traveling in vacuum is described by the following wave function. E is 5 volt per meter cosine kx minus omega t plus phi, okay, where k is the wave number and all. So find the following quantities. Okay. So let me, so here's the x-axis, y-axis, okay, and if you turn a right-hand screw from x to y, so if you turn a screw from x to y, which way would the screw move? It would move out of the paper, and that would be the direction of z. Okay. All right, so the electric field is given in terms of, the electric field is given like so. E naught would be the amplitude of the electric field cosine kx minus omega t plus phi. So the various quantities, E naught is 5 volt per meter, K is, well, K is, we'll come to K in a second. There is omega, and there is phi. That's the, that is the phase constant, okay? This is the wave traveling in the x direction, okay? And, oh, by the way, so J hat. So the electric field is, so what's happening is the electric field is in the xy plane, okay? So the electric field would sinusoidally vary in the xy plane, okay? And the magnetic field, oops, so this is the electric field, E naught, and the magnetic field, of course, is perpendicular to the electric field, so the magnetic field will vary like so, like that, okay? And this is the direction of travel, so that's the direction of the S vector, pointing vector, that's the direction of travel. So again, as t increases, x increases, so that's the direction of travel, okay? All right, now let's calculate the various quantities. Find the following quantities. A, the amplitude of the electric field is E naught, which is equal to 5 volt per meter. Frequency, omega is 2 pi f. F is omega by 2 pi. And omega, you can see from this equation, is 6 times 10 to the 9 per second. Okay. 6 into 10 to the 9 radians per second divided by 2 pi. And that's 0.95 into 10 to the 9 hertz. 1 over second is hertz. Okay. All right. C, the wavelength. Okay, this is an electromagnetic wave. The electric field of an electromagnetic wave traveling in vacuum. What is the speed of electromagnetic waves in vacuum? C. Okay. C is F times lambda. So the wavelength is C over F. We just figured out the frequency, so the wavelength is 3 times 10 to the 8 meters per second, and frequency is 0.95 into 10 to the 9 1 over a second. Okay, so 9.5, so 3 divided by 9.5 meters, 1/3 of a meter. So 0.32 meters. So the wavelength of this wave is about a foot. Okay. D, what else did I want? The direction of travel of the wave. And again, from this equation, as time increases, you can see x has to increase. The direction of travel is the direction in which the phase is held constant. Okay? So as t increases, x increases. What if you wanted to make this wave travel to the left? What would you do? That would be a plus. As time increased, x would have to decrease to keep the phase constant. Okay? All right. So the wave travels to the right. Positive x direction. And the associated magnetic field wave. Okay, so now the magnitude of the magnetic field is given by E naught divided by C. Okay. The magnetic field, the strength of the magnetic field in an electromagnetic wave is related to the electric field like so. So B naught, there's the magnitude 5 volt per meter divided by 3 into 10 to the power 8 meters per second. Okay, and all those combined those units will give you Teslas. So this is 1.67 into 10 minus 8 Tesla, and we'll write it as 16.7 into 10 minus 9 Tesla, nano Tesla. Okay, so that's the amplitude of the magnetic field. We still have to write the expression for the magnetic field.
So the wave travels in the what?
In the x direction, positive x direction. Just one second. Okay, this is how you write positive.
It's plus VE, right? It's positive.
Yeah. So that's the physicist symbol for positive. Well, it makes perfect sense, doesn't it?
Plus X, right?
Hmm?
Is it plus X or is
Yeah.
I am positive that's a weight, right?
All right. Now, so going back to this, okay, the electric field, magnetic field, and the direction of travel. So you turn the electric field to the magnetic field, and that if you turn a screw that way, that'll give you the direction of travel. Okay. So E cross S. No, I mean E cross B gives you the pointing vector 1 over mu naught times E cross B, and S is the pointing vector is the direction in which the energy is flowing. It gives you the intensity of the electromagnetic wave, and that gives you the direction of travel. So E cross B gives you S. Okay. So B has, since the direction of travel was that, B has to be in the Z direction. Okay. So now we'll write the expression for B. So the magnetic field is given by B naught, and it's cosine, so they are in phase, cosine kx minus omega t plus phi. Okay. So we can write those numbers now, 16.7 into 10 minus 9 Tesla, cosine k is 2 pi by lambda. Lambda was 0.31 meters. X minus omega. Omega is 6 times 10 to the 9. T plus phi, and phi is, what was phi? 0.4 radians. So there is the mess. Okay. Again, it's well, I was going to rewrite that, but there is the magnetic field. Oh, it's in the z direction, k hat. The magnetic field vector is in the z direction. Okay. So there is b x t. Okay. Okay. I will stop this recording while, oops, while you guys